Hello everyone, good evening. Am I clearly audible? Okay, thank you. So in last session we performed a hands-on exercise of uploading data on ThinkSpeak cloud platform on a channel created by us, right? And in that session we learned how to use APIs provided by cloud platforms to interface our devices with them. Okay. On the cloud platform side, you can collect your data and have your data logged. At the same time, you can have your data plotted. So I'll just walk you through this session, although most of the topics were covered in the last session itself. But anyway, this is just a revision, a theoretical revision of the concept we discussed in the last session. Okay. So here first, let us understand what is a cloud. I hope these topics were not covered in the last session. Were they covered in the last session? Okay, so let me just get you familiar with these basics, and then we will, perform a hands-on session. Or first connecting our Arduino board, along with the sensor connected to it, LM35, to internet with the help of ESP01 Wi-Fi module. So that is going to be our hands-on exercise in today's session. So it's going to be a mix of session number 7 and session number 8. Okay, so we are starting our discussion with cloud computing. Okay, see, advent of IoT has introduced so many new computing paradigms, and like we had been familiar with desktop computing, in fact also with mobile computing. Okay, cloud computing was introduced later, and then came, nowadays people are talking about edge, fog, and roof computing. So there are so many different types of computing paradigms. So it's all about running your applications, I mean the software, at various point in a given network. Okay, so computing is no more you know uh, stand alone, or computing doesn't happen in silos now. Now this is the era where computing is always distributed. Distributed means you have your computing, the all those software applications which are responsible for performing various type of operations on data, hosted on different nodes in a network. Okay, so you can have, let's say, a software application running on your IoT endpoint, for example, an electronic lock, or a washing machine, or a smart TV. Right, so you can have applications running on this endpoints. These applications connected to gateways, where you can have applications running which are responsible to perform, computing called edge computing. Okay, and most of these operations, edge computing involves operations like store and forward, aggregation, and performing real-time computations to generate control signals for your endpoints in a local environment itself. Okay, you move forward from edge to cloud, and on cloud we generally store data for long-term analysis, and the insights extracted from there could even be made available to your applications running on backend. Backend means either on user devices or on business, on-premises infrastructure, hosting solutions like ERP or CRM solutions, right? So the objective here to have all these solutions connected to each other and working cohesively and in a collaborative manner to offer a transparent, and experience to end users. Okay, so end users never come to know whether computing is taking place on their device or at the endpoint or on cloud platform or at the edge or somewhere else. So there are multiple nodes in a given environment where you can have uh, your computing deployed. Now, most important node where most of your computations would be deployed, is obviously a cloud, right? So what the question is, what is a cloud, right? So cloud is basically a internet connected cluster of high-end servers. Okay, and these high-end servers, they're not just going to be one server. At a physical point, you can have group of servers running. Okay, and this group of servers are called data centers. Okay, so you can have data centers located at various points, and these data centers uh, could be connected to each other. Okay, so you can have data centers connected to each other with the help of internet. Okay, again offering a distributed environment to have your computations deployed. Okay, this cluster of data centers are owned by organizations, okay, and are made available to uh, organizations. So there are two types of organizations. Okay, one type of organization are those who own this resources. I mean to say this cluster of data centers, and there are other organizations who are there to use these data centers to have their applications and data hosted. Okay, so the most important part here is this data centers, these are available on a shared model to their customers. Okay, and this resources on these data centers could easily be configured and are managed by those organizations who own them. Okay, and this data centers are accessible over the internet. And here, like these organizations, they provide you a web portal, which act as a GUI to interact with these resources and have them configured. Okay, so for example, you go to aws.amazon.com, and there you would find a portal where you can create a virtual machine, you can create a storage facility, short-term storage, long-term storage, and you can have your data stored in them. Okay, you can also host your applications, in the form of serverless computing engines. So there are multiple types of hosting services and data storage and analytical services being offered by cloud platforms. Okay, most see let us first have a look at the type of deployment models employed by organizations, right? So the first type of cloud platforms, or this fully managed set of computing resources, are owned by organizations. For example, Amazon is a leading player when it comes to public cloud platform. Microsoft Azure is second example. They are at par with Amazon. Google has entered into this public cloud platform domain, and there are many other players, right? So this why do we call them public cloud platform? Because this platforms are open to public. Okay, whoever pays would be owning resources over there, right? And so most of these resources are available on pay as you go basis. Private cloud platforms are those computing infrastructure which are owned by a single organization. So let's say you can have an organization having its own data centers, and these data centers connected to each other over the internet, forming a cloud, right? So if a cloud is owned by a single organization, we call it private cloud platform. And most of times, this This platforms are created by organizations, those who are interested in keeping their data private and where security of data is primary concern, right? So organizations like banks or defense organizations, they create their own computing infrastructure called private cloud platforms. Okay, then there is the third deployment model called community cloud platform. This community cloud platforms are owned by a group of organizations, and obviously, when a group of organization is owning a resource, it means all the concerns are also going to be commonly shared. These concerns are not just security and privacy, but there are other management and administrative related concerns, right? So it's going to be a joint responsibility of all the organizations owning this community cloud platforms. A hybrid cloud platform is actually a combination of two or more above listed models, right? So, for example, you can have, an organization can have a private cloud platform or on-premises infrastructure, and at the same time this infrastructure is connected to a public cloud platform offered by organizations like Azure and I mean say Microsoft and Amazon, right? Hybrid cloud platform is the most commonly employed cloud computing strategy by organizations, especially by IoT organizations, right? uh, the reason is, most of the organizations uh, would like to keep their data as much private as possible. Okay, so an organization may decide to have a set of data or applications hosted and running their own environment. At the same time, rest of the data and applications which may not hold that much value for organizations may be migrated to uh, public cloud platforms, right? So hybrid, and especially if you look at for example let's talk about smart factories. So in a smart factory environment, these machines they churn out petabytes of data, and most of time this data have to be analyzed in real time. So this is the second type of requirement which forces organizations to have computing deployed locally. So a smart factory solution would employ a hybrid model wherein like those computations which have to be performed in real time deployed in their own environment, and rest of the data for long-term analysis, for integration with third party solutions, and for archiving, they can have your data migrated to cloud platform as well as applications deployed on cloud platform, right? So hybrid is the highly prevalent computing cloud computing model being employed by organizations, especially in IoT domain. Okay, so these are just a quick overview of deployment models: public, private, community, and hybrid. Okay, now let me help you understand the service models. So we have three types of service models, starting from infrastructure as a service. The second service model is called PaaS, platform as a service, and third one is called software as a service, or SaaS. You know, so infrastructure as a service means the organizations who own cloud platform, they offer infrastructure, you know, in the form of a service. For example, a server, a storage solution, or a networking solution could be offered to a customer as you know a hardware infrastructure. Now, organizations, those organizations who opt this infrastructure as a service uh, service model, they they are responsible to build, because they only get hardware, right? For example, you will just get a server, nothing running on it, you know, uh, right? A storage solution, not it could be available to you in a configured manner, but with will not have anything stored in it. Okay, so the organization which go for IaaS model, it's their responsibility to build the runtime environment, deploy operating systems, middlewares, and databases. And on top of them, they they can create their own applications, with the help of the services, software components, which are mostly integratable, which could easily be composed, I'm going to say, which could easily be integrated with each other to compose larger solutions. Okay, so when an organization go for infrastructure as a service model, it's their job to deploy the second layer on top of infrastructure, the runtime OS, middleware, databases, and then create applications, available to their customers in the form of services. PaaS model, uh, the cloud service providers, let us call them CSPs. This cloud service provider, they offer hardware infrastructure, at the same time a runtime environment, operating system, middleware, and databases of customers' choice. So let's say if you ask, for a Windows virtual machine, that Windows virtual machine would be created. If you ask for, a MySQL database management system running on it, this all components would come pre-loaded on your virtual machine. Okay, so this type of model where you not only get a server or a storage or a networking solution along with this, you also get runtime OS, middleware, and databases fully configured. Okay, the third type of service model is obviously SaaS, the most popular one, the most commonly used, uh, you know, and in SaaS model, a cloud service provider provide hardware infrastructure, a runtime OS, middleware, databases, fully configured, as well as, uh, ready to integrate or integratable software components available in the form of services. Okay, for example, on AWS, you get this IoT stack of services. Okay, a gateway which could be configured to collect data from your devices. You can have a database solution like DynamoDB, which could easily be configured to have your data ingested and stored for further analysis, right? You can have some kind of visualization tool, Amazon QuickSight, to build dashboards, right? So all these components come as integratable components, and your job as a customer, let's say if you want to create a cloud-based solution, you just integrate those components to each other and build your solution. Okay, so we are going to explore this composition of an IoT solution on cloud platform. I'll share, I'll help you understand all these things with the help of practical exercises. Just keep these terms in mind. Okay, infrastructure as a service, platform as a service, and software as a service. These are three service models offered by cloud platform service providers, CSPs. Okay, moving onward, and this is what we experienced in the last session. You know, see, data aggregation, and what does it mean? It is a process to collect, process, and transform data to be suitable for statistical and other advanced form of analytics. Okay, so data aggregation means data coming from devices have to be collected, have to be stored, have to be pre-processed to be converted into a form suitable for statistical and other advanced forms of analytics. And those advanced forms are, for example, predictive, prescriptive, or diagnostic. You know, the primary objective of data aggregation, why do we need to collect data on cloud platform? What are we going to do with them? So the primary objective is to derive meaningful and actionable insights. You know, see, this data holds value. Okay, and this value is always contained in data in the form of insights, the trends, patterns, interrelations, logics, right? All this have to be extracted from data, and this extracted collection of data help organizations make meaningful and decisions. Okay. When it comes to data, there is something called data encoding and modeling. Data modeling, and I'll share some resources to help you understand data modeling. So data modeling is the idea of properly formatting data. Okay. Let's say at the source itself. So let's say from your device itself, you can have data modeled properly. For example, in this format, JSON, XML, or CSV format. So either you send raw data to cloud platform, and on cloud platform you can have this data stored in this standard formats, or a better solution is to data modeled and encoded in a standard format at the source itself. So this so that uh, you know uh, the it, it could easily be ingested on the cloud side. Okay. So it depends on the solution builders, whether they would like to have their data modeled and properly encoded on the source at the source itself, or get it done on the cloud platform once your data reach there. Okay. So this is just a basic overview of what we did in the last session. We are exploring ThinkSpeak cloud platform. Okay, so let me once again open this cloud platform. Okay, so this is the cloud platform ThinkSpeak, and ThinkSpeak. What we did in last session, we created a channel over here, right? We can have a channel, and over here on our channel we can have data stored. Okay, so for example, this is anyway. Let me just remove this thing. Okay, so I have data uploaded over here, right? And a plot has been created out of the uploaded data. uh, Guys, why didn't you tell me? My screen was paused and no one bothered to tell me. Come on, so why did you guys hold back? You know, see, I was walking you through this presentation, the cloud computing, the deployment models, service models, and data aggregation techniques. Anyway, so let me do one thing. This PPT is available on LMS. Can go through it later. Okay, my screen was paused, and I got a message from one of you now in the chat window. Okay, so there was a confusion. No props. Okay, sorry Aditya, even I did not. Hi Aditya.
Yeah, but I was not able to redirect. I was hearing your voice. What kind of
No, it's
so
fine.
that's why.
So you guys do one thing.
Yes.
Even your
Yeah.
voice is also cracking up. So you do one thing. This presentation is available on LMS. Guys, go through it, and whenever if you find anything that you would like to discuss with me, we can have uh, a recap of the topic that I just discussed with you. Okay, no props. So let's move forward. So SaaS is the model, I was talking about. And over here on this cloud platform, so I'm not directly, taking you to Amazon or, uh, you know, mm, Azure. So if you go to For example, Amazon, over there you will find, just go to aws.amazon.com, and in the product section you would find hundreds and thousands of services. For example, analytics, you have, Amazon Athena, Amazon EMR, Cloud Search. In the IoT itself, we have IoT Core, FreeRTOS, Greengrass, IoT One Click, IoT Analytics. So we will have discussions on all these services, especially on this cloud platform. AWS has thousands of services, but we'll restrict our discussion to AWS IoT stake of services. Okay, the listed services over. For example, AWS IoT Core, which would allow to get your connect devices connected to AWS platform. Okay, so this is IoT Core. We'll talk about this service. I'll teach you how to have your devices connected here. But why am I, starting off with ThingiSpeak? Because it's easier to understand things over here. Okay, so in the last session we created this cloud platform, this channel on this cloud platform, and we learned how to use these APIs, HTTP APIs, especially the first one, right, to upload data, if you remember. Okay, we have other set of applications here. So if you go to apps section, you would find applications, which are responsible to generate actions. For example, there is an application, ThinkTwit, which would connect your device to Twitter and enable your device to send alerts. There is time control, to automatically perform some kind of actions, uh, and trigger an action on your device. React would allow you to have your data monitored in real time on cloud platform. Okay, Talkback would allow you to have commands stored for your devices, so you can have a repository of commands stored over here for your devices. Thing HTTP will allow you to have the React and Talkback connected to each other. So anyway, this is too early to talk about these services, because this mostly we will have discussions on this in tomorrow's session, if time permits, or else next week's Saturday's session. Okay, what we are going to do today, as we learned in the last session, we have our Arduino board with us, right, with LM35 connected to it, and we have, in the previous sessions, in second last session, we wrote an application, uploaded it on our Arduino board to collect data, temperature data from LM35, right? This is what we achieved. So data acquisition, yes, we have learned this part. The cloud side means creating a channel, to accept this request, the request which is here on my screen, and then, parse this request to take the data out from here, and then have this data logged and plotted. So these two parts have already been covered. Now what we are going to do today, we will have to connect, to establish an end-to-end communication between Arduino and cloud. The first thing we need to do over here is we need to connect our Arduino board to internet, right? Our Arduino board to internet. Now what is internet? See, internet is a global ubiquitous network of information systems. Okay, so on internet you will find thousands of servers holding enormous amount of data, and the servers are connected to each other. Even you can have your clients connected to server to retrieve this information stored on them. See, this internet is available to us as an economical communication infrastructure. Okay, and till now we had only connected our conventional computers to internet. Conventional computers means laptop and desktops, and now mobile phones too, right? But with the advent of IoT, now we have new generation IoT devices getting connected to internet in the form of IoT endpoints. Okay, and internet is the only way to reach to a cloud. So let's say if you want to connect your device to cloud, it's only internet which is available to you. The only channel, or only connecting medium available to you to have your devices connected to internet, connected to cloud platform, is obviously internet. Okay, so here, our first challenge is to connect our Arduino board to internet. Once it is connected to internet, then internet will help us, gaining end-to-end connectivity. Okay, but question is, how are we going to connect Arduino board to internet? Okay, see, internet is available everywhere, and you will find you know access points, APs, access points or hotspots. you know so those network points, which offer internet as a service, are called access points. Okay, and there are three ways available to us, to have our devices connected to internet. The first technique that you use is uh, you know uh, connecting your device to internet with the help of an Ethernet, module or Ethernet board. Okay, so most of times, conventional computers like laptop and desktop come with uh, internal LAN adapter or network interface cards, NICs. And on your laptop and desktops, you find that LAN port, right, where you can put RJ45, cable, or UTP cable to connect your laptop or desktop to a local area network where internet is available as a service. Okay, for your Arduino board too, you can easily find an Ethernet shell, you know, Arduino compatible Ethernet shell. So you can have this Ethernet shell connected to your Arduino board, and once Ethernet shell is connected to Arduino board, what you will get RJ45 port. Okay, and from there you can use a cable to connect your Arduino board to a local area network where internet is available, as a service, right? So that is one way of connecting Arduino board to the internet. Okay. The second possible method is, using, you know, a GSM or GPRS module. Okay, wherein like you can put a SIM, those SIM that you use in your mobile phones, right? So you can put a SIM in a GPS or GSM or GPRS module, and once this GSM or GPRS module is connected to your cloud, I mean to say your board, your Arduino board would be connected to a cellular network, and this cellular network will allow your Arduino board to be connected to internet. Okay, so this is the technique that we use on our mobile phones. We connect our mobile phones to internet using cellular, communication facility. Okay, the third and more popular method available to us to have our devices connected to internet is obviously Wi-Fi, right? So you can have a Wi-Fi module connected to your or interface with your Arduino board, and this Wi-Fi module will allow you to uh, you know uh, connect your Arduino board to a Wi-Fi access point. Okay, now out of these three, because Arduino board or this ATmega 2560 microcontroller mounted on Arduino board doesn't have these capabilities, neither Wi-Fi nor ATH nor a GSM. So we'll have to select one of these three techniques to have our Arduino board connected to internet. Now I'd like to ask you guys which one out of these three is best method to have our Arduino board or any other IoT endpoint connected to internet. Which one you'd like to select out of these three options? Okay, so answer is obvious, right? And I'm getting this answer from all the participants. Wi-Fi, right? Now, question is why Wi-Fi? Okay, see the best thing you are going to get with Wi-Fi is your compared to Ethernet. Compared to Ethernet, Wi-Fi will provide you mobility, right? Okay, but the next obvious question is why not GSM or GPRS? The reason is GSM or GPRS they consume lots of power. Okay, so Chandrasekhar, he says GSM is the best as it can be deployed anywhere. Yes, so Chandrasekhar, especially for mobile systems, for example, cars and other systems which cannot stay connected to Wi-Fi network it most of times because of their mobility, right? So for this type of systems, we prefer to go for GPRS, right? But for systems which are deployed indoor, are most of time mobile in a particular area, right? So for those type of system, we prefer to go for Wi-Fi because GSM or GPRS modules they consume lots of power, you know. So power is one of the constraint. One of the limitation, power consumption is one of the limitation with GSM and GPRS module. Compared to them, Wi-Fi consumes very less power. Okay, so because of support for higher data rates, uh, uh, low power consumption and compactness. Wi-Fi modules are smaller compared to GSM GPRS modules, right? So and Wi-Fi can also be built on chip. You can have Wi-Fi available on chip. So there are SoCs. For example, the next platform we are going to explore in this training session is a Node MCU, right? So Node MCU, which is a board like just like Arduino, it is based on a chip called ESP12, which comes with on-chip Wi-Fi. Okay, so next prototyping board we are going to use most probably in the next week's exercise. Will give you an experience of working with a microcontroller which comes with on-chip Wi-Fi. Okay, so these are the few reasons why we prefer to go for Wi-Fi instead of GSM and uh, Ethernet options. Okay, so good thing is we have this Wi-Fi module available in our kit. The Wi-Fi module which is there in our kit is ESP01. Okay, and this ESP01 could easily be interfaced with your Arduino board using UART, you know, UART, which has already been covered in this training program, right? So the communication between Wi-Fi module ESP01 and your board would be UART. So from Arduino board we can send commands required to configure this Wi-Fi module, and our messages. For example, this HTTP message to ESP01 module. ESP01 module will hand over it to the access point, your home router or office router, wherever you are accessing this internet from, and then from there onward, it is the responsibility of this group of routers on internet to move your message forward and finally deliver your message to the cloud server. Okay, so the experiment we are going to perform now is interfacing ESP01 with Arduino board. Okay, so I'm going to share a circuit diagram with you to have this ESP01 module connected to your uh, Arduino board. Okay, see ESP01, as you can see here, is a Wi-Fi SoC built by ExpressIF. Okay, ExpressIF is the manufacturer, and the picture of this module is here on my screen. I would suggest you guys to write down names of these pins on a piece of paper. Okay, that will help you in making connections. Okay, so please do one thing: write these names down on a piece of paper and keep it handy with you. We this module has 8 pins. The pins have names. Okay, now while when you write this names on paper, be careful with the orientation, because the pins are on the opposite side. As you can see here in this picture, this zigzag pattern is antenna. Okay, and pins are on the opposite side. So the first pin here, this pin is VCC. Okay, this pin is VCC. Okay, be careful with the orientation. Okay, this pin here exactly at diagonally opposite to VCC is GND, ground. Okay, the pin just opposite to in the opposite row to VCC, this pin is RXD. Okay, the pin diagonally opposite to RXD, exactly opposite to GND, is TXD. Okay, see, names are written on this side, the pins are on the opposite side. Okay, the third pin from VCC side, this third pin is pins are at the other side, right? This pin is your CHPD. So we are just gonna use this 5 pins. VCC and CHPD has to be connected to power. TXD, RXD will go to microcontroller. GND will be connected to GND. That's it. We are just going to make 5 connections. So either you write these names on a piece of paper, or else just take a screenshot of my screen and keep it handy with you to build these connections. Okay. Once you are done with writing names, let me know. I'll share a circuit diagram with you. So it's chip enable pin. We know this pin is, we call it chip enable pin. These pins are used to enable chips. I mean, say the SoC will only work when this signal is available, CHPD. It is ESP01, Sagar. ESP01. I'll share more information about this. In fact, the datasheet is available on this link, which is here on my screen. Sure, Sagar, I'll share the list. Guys, once you're done with writing the names, let me know. Okay, so this link, this is the datasheet of ESP01 module. Okay, have you taken down the names? Okay, I'm moving on to next slide where, okay, next thing, this module is there in your kit. So please take this module out from your kit. I'm moving on to next slide where you would find a circuit diagram, you know, to connect this module ESP01 to your Arduino board. Okay, please make these connections as given here in this circuit diagram. Now let me zoom it in for you guys. Okay, so I'll just zoom it in a little bit. Okay, so it's, see, this, whatever we're going to do over here, we are connecting ESP01 module, the Wi-Fi module, to enable our microcontroller to communicate with or to connect to internet. Okay, so this ESP01 module we are connecting to Arduino board on port number 0, serial port. Okay, and don't get confused here. TX off, the TXD of ESP01 is directly connected to TX0 of Arduino board. Okay, RxD of ESP01 is directly connected to RX0. Okay, so we are making direct connections. I'll tell you why are we doing this, but first please make the connections. See, you will also have to use your breadboard. Okay, and be careful, this pin here, see, this wire is coming from Arduino board from 3.3 volt pin. Okay, the pin over here, the wire should be connected to 3.3 volt pin. Be careful, if you accidentally connect it to 5 volt pin, you know, your module will get damaged. Okay, so be careful over here in the power supply section. Connect this wire to 3.3 volt, bring this wire to breadboard. Make sure on breadboard you put all three wires the way it has been shown here in this circuit diagram. Do not use this block. Okay, if you use this block here, you will have to put three wires vertically, but if you use this block, you will have to put all three wires in the same row horizontally. Okay, in the same block. So 3.3 volt being taken out from Arduino board, you know, will be connected to CHPD as well as VCC pins of ESP01. Vishal, RX and TX will directly be connected to RX and TX, no crossovers. Okay, no crossovers. RX will go to RX, TX will go to TX. I'll tell you why are we doing this. Okay. Okay, Jitendra, let others complete. Abhishek, CHPD is chip enable pin. Chip enable. Unless you connect this to module, the module will not get signal to enable its circuitry. So usually on ICs we find a pin which is responsible to enable the internal circuitry. So it's not always we do not use power cycle to uh, restart chips, uh, so we can have, let's say, power connected all the times, and chip enable pin can be used to enable or disable the chip. Guys, let me share my webcam. Okay, just hold on. Okay, so I have my ESP01 module connected to my breadboard, and through breadboard to my Arduino board. Okay, once connected, ESP01 modules, the red color LED on ESP01 module will glow. Okay, that indicates the power. So as you can see here on my webcam, the red color LED on ESP01 is glowing. So that is normal thing. If you see red color LED glowing, it means it has started getting power from Arduino board. Okay. Okay. Are you all done with connections? So if you want me to wait for you, please drop a message in chat window. Okay, Sagar. Okay, I'm waiting. Raj Surya, yes, as you can see here on my webcam, your ESP01 module has a red color LED, and that LED will glow once you power it up. So I would suggest you guys to make all the connections first, and then you connect your Arduino board to your computer. Surendra, we need two 3.3 volt power supply. Our Arduino has only one, right? So we are taking it from Arduino to breadboard, and then we are bifurcating it and connecting it to those 2 points on ESP01 module, right? We just have one 3.3 volt power supply in the power supply section. This is why we are taking it out from Arduino board to breadboard, and from breadboard we are using two wires to connect the same point to CHPD as well as VCC. GPIOs are general purpose input output pins. Sarthak. GPIO stand for general purpose input output. RST stand for reset. So we are not going to use these pins at this point of time. GPIOs are pins to interface any external component with this module. These pins are programmable pins, and RST is to reset this module. But anyway, we don't use these pins at this point of time, so leave them as it is. Just make these 5 connections, that's it. Okay, Vishal. So guys, I'll keep this. Okay. So Mijit and Vishal have completed connections. Others? So Sarthak, those pins are used for configuration settings, state and keys. Okay, I'll wait for Ajay, Adit, still working on it. Raj Surya, if LED doesn't glow, do not worry. Okay. No problem, Surendra. You can use this PDF document available on LMS. This entire exercise would be available on LMS. Okay. 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 So if you're okay with your connections, what I'm going to do, I'll share a set of instructions with you guys to proceed with next steps. Okay. Just hold on, please. Okay, so I'm just keeping this circuit diagram open on one side of my screen for those who have not yet completed connections. Okay, I'll keep it open on one side of my screen, and I'll keep this PDF document open on the other side of my screen. Okay, please follow these steps. Complete the steps up to step number 5 and let me know. Okay, 1 2 3 4 5. First, you will have to remove those 2 pins connected on RX0 and TX0. You will have to upload a blank sketch on your Arduino board, and to do so you will have to open Arduino IDE, open a new file, and then you'll have to upload a blank program on Arduino board. Once done, put your RxT0 and TX0 wires back as is given in step number 3. Then, as given in step number 4, open your serial monitor window. In serial monitor window at the bottom, you will find line ending options and baud rate selection options. Okay. Make sure all these 5 steps you will have to complete in the given sequence. Please complete these 5 steps, and as soon as you get OK, let me know. A OK response from your ESP01 module would indicate that your connections are proper. Okay, Jitendra, blank means those 2 functions have to be there. Okay, setup and loop function have to be there. Just go to your Arduino IDE. Okay, click on File, New, and these 2 functions have to be there. Okay, setup and loop. Do not delete them. Sagar, you don't need to end this command. Just send the command. You simply type in your serial monitor. Okay, so when you open serial monitor, in the serial monitor you will see this line ending option at the bottom. Make sure you make these connections, and then in this send box type AT and then click on send. OK coming back from your module indicates that your module is ready. Okay. So guys, if nothing is coming, please check your connections. You type simply AT over here. If you get OK, the connections are proper. If not, check your connections. Okay, the circuit diagram is here on my screen. I'd suggest you to check your connections once again. Okay, complete up to step number 5. Yes, Sagar, Rx goes to Rx, Tx goes to Tx. Be careful with the orientation. Pins are on the opposite side, not on the antenna side. The pins are on the opposite side. Be careful with the orientation. Those who are not getting okay response, please check your connections once again. Jitendra, if your connections are fine, you should get okay response. Not getting okay, it means your connections are not proper. Okay, Bala Murugan. Sagar, your LED on your ESP01 module. It glows when you power it up. But anyway, see, it's hardly 5 wires that has to go from your ESP01 to Arduino board. And the circuit diagram is here on my screen. Okay, so are you getting okay response, Sagar? Then there is something seriously wrong with the circuit diagram. Please check it once again. Okay, Gaurav. Those who are not getting a okay response, I cannot do anything. I cannot help you out. I shared the circuit diagram. Check your connections. Look for loose connections, or check whether you have connected to 3.3 volt or any other pin in the power supply section. Okay, those who are getting okay response, it means your connections are proper. Now you can use rest of the commands given in step number 6 one by one to connect your ESP01 module to your home router. Do not forget to replace your SSID and your password in the AT plus CWJP command. Okay, so I'll show you quickly on my like I have my ESP01 module connected. I'm sending 80. It says okay. I'll send 80 plus RST, which is to reset the module. 80 plus GMR, okay, to find out its firmware version. 80 plus CW mode equal to 1 to configure it in uh, you know session mode, then AT plus CWLAP to list available access points. Okay, AT plus CWGAP. Anyway, it's already connected. I'll just use this command to show you. It shows me the name of the hotspot it's connected to, and AT plus CIFSR will print IP address. You know, so this you simply send these commands one by one in the given sequence as given in this step number 6 to connect your ESP01 module to your Wi-Fi router. Once connected, you know, let me know. Sarthak, SSID is your Wi-Fi hotspot name, the name that even appears in your mobile phone. When you search for Wi-Fi, the name appears in your mobile phone. Whatever name appears in your mobile phone. If you have a home router, its name appears in your mobile phone, right? SSID means access point name. Uh, okay, Sagar. Okay, Sagar, check your settings, baud rate settings. Have you set it at 115200? Then it should work, boss. I suggest you to remove the power supply connection and put it back just to reset your module. Ajay, I'll share this PDF on LMS. Might have been uploaded by our support team. So Vishal, with AT plus CWJP command, you need to specify, this is the entire command. Jitendra, are you getting this error when connecting when uploading the code? Okay, so just hold on, let me unmute you. Jiten, have you removed those two wires RX0 and TX0 from pin number 0 and 1? Jitendra, can you hear me? Guys, use audio mode. I cannot read and spawn you, in chat window. Jitendra, I would suggest you to, disconnect your Arduino board, close your IDE, connect your Arduino board first, and then open your IDE, and then try uploading your code. Okay, that will allow your IDE to detect Arduino board. Sagar, where are you? Sagar, what is the problem you're facing?
So now it says boarded COM4 is not available. I think I used a communication port, USB port, from the one that I was using last week.
Okay,
So I just
so
need your help to set up my, because in my Arduino it shows me only one port, that is COM3, and but initially it was I think on COM port 4. I have opened up my computer settings.
that won't be a problem. Whichever port is being
I
displayed
don't
here
know.
in the tools menu, simply in your Arduino IDE, go to tools menu, and you see a port listed with Arduino Genino Mega written in front of it.
So this is not written. This is not written in my case. What I can see is just serial ports and COM3 and ahead of COM3 there is nothing written like on which port
Okay,
my
so do one
Arduino
thing.
is connected.
You
Yeah.
remove the Arduino board from your computer. Okay, unplug it. The moment you unplug
Yeah.
it, whichever port assigned to it, it will disappear from the list in your device manager.
Right. It's not there in the device manager on Arduino, right?
Yeah, you keep looking at device manager and
Hmm.
disconnect your Arduino board. If it is COM3 would disappear from that list. It will be removed from that list.
Okay. Fine. So I think it was COM4 and I need to connect it. If I reconnect it, right, to my computer, to my laptop,
Hmm. Hmm.
right, and it says Arduino Mega on COM4, right? But when I go to my tools and port, all right, now I think it gets connected. Yeah.
Okay.
Now I'll try. Just give me a
Yeah,
minute, sir.
select the port, upload your code. Now,
Hmm.
while uploading code, make sure your those two wires have been removed from pin number 0 and 1. Okay.
Okay.
Vishal, the second last command is AT plus CWJAP question mark. Okay, and that is just to verify, Wi-Fi connectivity. Okay, guys, so let me do one thing because we are losing lots of time. So let's utilize this time. I'm giving you a 15 minutes break so that those who have not completed these steps up to this level, uh, they can once they like this break would allow them to get in sync with others. Okay. So we are going to have a 15 minutes break, okay? And then in this 15 minutes break, those who are facing problem, please repeat the process, check your connections, and run all these commands is given in these instructions on the right side of my screen. Yes, Adit.
Sir, I have tried multiple times. I'm not getting the output as a command response is okay, but every time when I send the command AT,
Mm-hmm.
the RX LED on this Arduino board lights up every time I send something. So
So
that means
RX,
it is
RX LED,
receiving.
it means you're getting something from your ESP01 module.
Yeah, I think it's receiving, but it's not showing on the serial monitor that okay or something. I've I've checked all the connections. I've checked everything.
But if your connections were proper, this would have been working. There is no
Okay, sir.
other option.
Let's see after the break if you show us that how did you do it. So that's in that way I would be better
See,
understand. I would better
on
understand.
serial
Yeah.
monitor side, you check two things. Are your settings both NLN AR and I'm going to say line ending
Yes,
options have to be
yes,
both
they are.
NLN
Yeah,
AR? Okay,
yeah,
CR I would say, and this has to be 115200.
yeah.
Okay, now do one thing. Momentarily power down your board by
Hmm.
removing the 3.3 volt wire. Okay,
Okay,
and
so
put it
I'm
back.
doing. Hmm. Okay,
You
I've
see
done
anything on
that.
serial monitor?
Nothing. I don't see anything on serial monitor right now, sir.
It means your RxTX connections are not proper. You double check your RxTX connections.
Hmm. Okay, sir. I'll do that. I'll do that. I've repeated the process 3 to 4 times right now. Maybe the power is getting there. Power is not has a not because the LED light on the this ESP01 is has lit up because that
Mhm.
is something that the power is coming. There's no situation of the power. Maybe the problem with the. I think I'll check the another cables. I'll try to connect with that.
Yeah, yeah,
Okay,
please,
sir.
please.
After the I'll come. I'll come after the
No
break.
problems, no problems.
Sure.
This is why I'm taking a break. Okay, that break will allow you to recheck your
Sure.
connections.
Yes,
Okay,
sir.
okay.
Thank you, sir.
And guys, if you could not complete the exercise, do not get disheartened because we can even help you performing all these exercises on weekdays. You know, So this document will be available on LMS as well as our support team will always be available on weekdays. In case if you find any difficulty working with hardware, you can contact them. They will help you completing all these exercises. Okay. If you can make it work during the break, please do it. If not, don't get disheartened. Okay. Focus more on the learning part. Okay, so I'm running a timer on my screen. We'll resume session exactly after 15 minutes. Meanwhile, please check your diagram. Those who have completed up to step number 6 successfully, they can enjoy the break. Okay, running a timer on my screen. We'll resume session exactly after 15 minutes. Okay, guys, break is over. So Majid, if you are not getting okay, I cannot help you out at this point of time. As I suggested, please, check your connections or else contact support team later, to complete this exercise. Okay, because it's online session, you understand, right? The limitation is I cannot physically check your connections. Okay, so Jitendra just did one thing. Jitendra, how did you reset it? By connecting ground to RST pin, right? Jitendra, how did you reset? Uh, okay, you removed all the wires and connected them back, right? Okay, so this is what I've been suggesting to those for whom it's not working. Guys, please check your connections. If your connections are not proper, there's nothing that there's nothing wrong with the commands. This are standard commands suggested by manufacturer. Okay. So anyway, let me help you guys. What are we doing exactly? Okay. So I'll move you step by step. Why are we doing this? Okay, Adit. Okay, Sagar. I suggested them. Okay, to check the connections. No problems. Okay, so let me help you understand why are we doing these steps? What are we trying to achieve? Okay, so as I just explained you, we have to first configure our ESP01 module. This module, which is Wi-Fi module, we have to first configure it manually to connect to available Wi-Fi access point. So it's easier on your mobile phones, right, or on your laptop. You simply select the hotspot name and then enter password to connect to it, right? So whenever you go to a new place, what do? You search for available Wi-Fi access points. You open your Wi-Fi settings, you see the list of access points, you choose the access points you intend to connect to your mobile phone or laptop. It asks for password, you enter it, and then you are connected, right? So this is what we are trying to achieve over here, but here the process is a bit complex. Okay, this ESP01 module understands 80 commands. See, this 80 stands for attention, and this 80 command is a kind of language that your module understands. Okay, so when you send command 80 to it, they send for attention, it says okay, right? So it means this chip, this tiny module, has a 80 command interpreter running on it. Okay, now what we have done over here to communicate directly with ESP01 module, first we disconnected the module from these two pins. Okay, connected it to our computer. Okay, connected the board to our computer with the help of USB cable. Okay, first we uploaded a blank sketch from our laptop. We uploaded a blank sketch on this microcontroller. You know why? Because this path, you know these two pins, you know are also connected to this USB port. Okay, and the same path is used by Arduino IDE to upload program and to communicate with microcontroller. See, if you keep your ESP01 module connected on pin number 0 and 1, that will make three systems connected to this UART lines, and that is an open violation of UART protocol. See, your UART protocol doesn't allow more than two systems to talk to each other at a time. Okay, so what we did here, first we disconnected these two pins from pin number 0 and 1. Okay, next we uploaded a blank program on our microcontroller to disconnect microcontroller from this path. Now once you upload a blank program, microcontroller, this chip gets disconnected from this path. Okay, after uploading blank sketch which has isolated this microcontroller from the path, we put this wires back. Okay, and that eventually establishes a direct connectivity between ESP01 module and your laptop. Getting the idea? What have we achieved over here? We did the first two steps, in fact three steps, to establish a direct communication between an application running on laptop, which is our serial monitor, and AT command interpreter running on ESP01 module. Is this clear to all of you? Why have we uploaded a blank sketch on microcontroller? To isolate it from this path and to establish a direct path between an application running on laptop, which is our serial monitor, and AT command interpreter running on ESP01 module. Is this clear to all of you? Okay. Now, in the next step, once this connectivity is there, then we started sending AT commands to ESP01 module. The first command AT, once you send it from serial monitor to ESP01 module, ESP01 module has to respond with OK. If ESP01 responds with OK, it means your connections are proper. Next command, which is AT plus CW mode equal to 1. Okay, I'm putting this command in chat window. AT plus CW mode equal to 1 configures, once this command goes to ESP01 module, ESP01 module configures itself as a station, okay, is a network node. See, AT plus CW mode equal to 3 command would have configured your module is an access point, which could even be available to other systems to be connected to internet. Okay, but anyway, we do not want to use it in access point mode. We just want it to work as a standalone uh, you know network node. This is why we have configured it in station mode by sending this command AT plus CW mode equal to 1. Okay, the next command, which is AT plus CW LAP, this command is to list access points. Okay, so when you use this command AT plus CW LAP, ESP01 sends a list of access points to serial monitor. Okay, in serial monitor you would see a list of access points, right? Now you'll have to select one of the access point, whichever is available, right, or whichever is known to you. Okay, to connect it to your ESP module to access point, we use command AT plus CWJP access point name and password. Okay, so as I'm sharing this command in chat window, in fact you have done it, right? AT plus CWJP command, JP stand for join the access point. So this command configures your module to be connected to given SSID with the given password. Okay, now once you receive a message, okay, connected to Wi-Fi, got IP, then you can use a command AT plus CWJP question mark, you know, CWJP question mark. This command is to verify, and in response to this command, ESP01 module will send the access point name it is connected to and its MAC address. Okay. The next command, final command, is AT plus CIFSR or CISFR, right? Whatever it is. So this command is to print IP address assigned to your ESP01 by your router. So this shows that your ESP01 is finally connected to your router, and it has got an IP address. That IP address is going to be printed in serial monitor. Okay, so I'll show you all these things once again, on my serial monitor. So I have my ESP01 module connected, and over here I'll start from scratch. Okay, the first command, AT, and as you can see here, the response we get is OK. Okay, I sent AT. The response is OK. Then optionally, I can use AT plus RST command. This is to reset the module. Okay, see, module resets, it prints, it sends lots of information. Okay, and then it says ready. In my case, it is connecting and getting connected to Wi-Fi automatically. So just ignore these three commands. You know why? Because my module is already configured, so it automatically connects to stored SSID. But anyway, in your case, this three responses would not appear. Okay. So once you receive ready, means your module has been reset. This AT plus RST is optional. Okay, not necessary to send all the times. AT plus GMR is also optional, which is a command. In response to this command, your ESP01 module will send its AT command interpreter firmware version. Okay, so as you can see here, to AT plus GMR, ESP01 module responds with this information: manufacturer's name, SDK version, AT command interpreter version, and release date. Okay, so all these responses are coming from AT command interpreter firmware running on ESP01 module. Okay, in the next step, we send a command AT plus CW LAP. Okay, and in response to this command, it will list access points. You see the list of access points? These are the hotspot or internet connections available, Wi-Fi connections available in my at my place. Okay, now out of this three, this is my Wi-Fi hotspot. Okay, this is my Wi-Fi hotspots SSID. This is the MAC address. Other parameters shows signal strength. Okay, now once I decided, okay, I have to connect it to my access point, what I'll do, I'll give it command AT plus CWJAP equal to my SSID, okay, comma, my password. Okay, so password. Okay, this is my password. Okay, I send this, and first it will disconnect. Why? Because it was already connected. So then again it connects, and then it says, okay, Wi-Fi got IP. It means ESP01 module now is connected to my home router, and it has got an IP address, a valid IP address on my home network. Okay, to verify the connectivity, I can use command. What do you want me to repeat, Jitendra? The same command? AT plus CWJP command? Okay, it's simple. AT plus CWJAP equal to, no space, okay? Equal to double quotes. Inside double quotes, I have to put my Wi-Fi hotspot name, comma, my password. Okay, so whatever password you have, you put yours. Okay, no space. Okay, in the entire statement, there shouldn't be any space. Send it. Okay, it disconnects, then connects. then it says Wi-Fi got IP. Okay. To verify connectivity, we can send command AT plus CWJAP question mark. You know, in response to this command, my ESP01 module sends this information starting with plus CWJAP, Wi-Fi hotspot name, and then other information, MAC address and other information, right? And finally, this command AT plus CIFSR. When you send this command, it prints the IP address assigned to it. Okay, so this is IP address assigned to my ESP01 module, and this is the MAC address of my ESP01 module as a response to AT plus CIFSR command. Okay, now what are these AT commands? See, AT command is a very popular, this application layer protocol, and application layer protocols are actually, programming languages, just like programming languages. Okay, and this AT command protocol is used, to configure GSM and GPRS modules. But now its uses has been extended to other types of modules, for example, Wi-Fi and Bluetooth, right? So most of the Wi-Fi and Bluetooth module understand AT commands the way this GSM and GPRS module understand, right? AT commands are simple commands, and the syntax will vary from modem to modem or from manufacturer to manufacturer. Okay, uh, I have a quick start guide, of ESP01 for ESP01. And this quick start guide contains all the commands, and there, I'm sharing a PDF document with you. And in this PDF document, you will find all these commands and their meanings. Okay. So here in this document, start from here. AT, okay, is response with okay. AT plus RST responds with this. AT plus GMR, AT plus W mode equal to 1. We did not use 3, we use 1. Okay. AT plus CWJP, how to connect your ESP01 to your Wi-Fi, verifying, and then finally printing the IP address. Okay. So all these commands have been given over here. I'm sharing this link in the chat window. You can download this document. Okay, to once again go through whatever I explained to you. Okay, Raj Suryadev, yes, AT commands. It's a popular text-based application layer protocol. It's a kind of language that GSM modules or GPRS modules understand, and now same has been extended to Wi-Fi and Bluetooth modules. Okay, is this okay, guys? Any questions from whatever we did? Yes, no, please respond, guys. Okay, Balamurugan. Okay, fine. So if you do not have any question, I'm moving forward. Now, once we have gained this connectivity, okay, so let me go back to my presentation. Okay, so once we have gained this connectivity, what is next? Okay, once we have gained this connectivity, we have put or connected ESP01 module, right? And connected ESP01 module to our Arduino board. And with ESP01, we have successfully connected our Arduino, right? This is our ESP01, and ESP01 is connected to the home router, and on the top of this, Arduino can communicate with home router. Right now, we are, using our laptop to send these commands to Arduino board, you know, and through Arduino board to ESP01, right? So our commands are going from here directly to ESP01, right? And ESP01 is communicating with this. Okay, do you understand this flow? Whatever AT command you are giving, this AT command has configured ESP01 to be connected to Wi-Fi router. So this first level connectivity. It means now whatever I send from here will go to this router, and then from this router over the internet we can reach to this server. Okay. So our next job, once Wi-Fi connectivity has been gained, the next job is to connect this this module. I would say the entire hardware setup here is a client to server, because the architecture we are trying to build this network on is client server architecture, right? It means it's this entire setup over here at this end will have to be connected to server as a client. Okay, the communication channel is internet. Okay, but the question is, when it comes to internet, the communication on internet is not as simple as point to point connection. You know, when it comes to internet, the communication is a different game. And it's a bit complex. See what happens when we hand over a message to a router, to first router. That message travels on internet. But there is a caveat here. The message that you will hand over to this router, to whom your entire this node is connected to, this router will demand the message to be handed over to it in the form of small packets, smaller pieces called packets. Okay, so if you look at the application, okay, the application layer in our current setup, the serial monitor application is acting as application layer. Okay, we have an app which is talking to this router using Wi-Fi connectivity, right? So if you refer to the layered communication architecture we discussed earlier, we have an application running directly on top of data link layer. In our case, data link layer and physical layer is nothing but Wi-Fi, right? And in our experiment, ESP01 is acting as this data link layer and physical layer. Okay, we have application running on our laptop which is communicating, you know, with this router. The application is serial monitor. Okay, so I will put the name of the application over here. Our application is serial monitor, and these two layers are actually our ESP01 module. Okay, and as you can see here, with the help of ESP01, our application is talking to this router. Okay, and this router is connected to other routers on the internet, and this group of routers are responsible for forwarding our message to reach to its final destination, which is server. On the server side, we have an application. Okay, and this application is waiting for this message to come, right? On server side, we have an application which is waiting for a message like this to come from here. Okay, and server is also connected to internet. Okay, On we do not know how uh, think is big people might have connected their server to internet, but let's imagine that or assume that this server is connected to internet using Ethernet, high-speed Ethernet uh, connection. Okay, so let's assume that on the server side, the is data link layer and physical layer is Ethernet. I hope this is clear to all of you, right? We have an application running on server which is waiting for the message to come from here, and logically these two applications will talk to each other. Internet will act as a physical channel. Okay, so let us get back to here. How will internet act as a physical channel? You know, so internet, the message never travels as a single piece. You know, the message that your client will have to hand over to this router, it must be handed over in the form of smaller packets. Okay, smaller pieces called packets. Okay, second thing, these packets must have IP address of source and destination appended in them. I hope you are getting this point. See, the first requirement here for your message to travel on internet is your message, whatever message your application generates, your message has to be broken into smaller pieces called packets. Now question is, out of these three layers, which layer would be responsible to break the message into pieces and append IP addresses with them? Can we assign this job of breaking message into pieces and then appending IP addresses, both source and destination, with those packets to one of the layers out of this three? Or do we need to insert a new layer somewhere in this model to take care of that job? What do you guys suggest? Okay, I have messages in chat window. Okay, so Surendra, his messages, he says, it seems like working like post department, every mail packet has addresses of destination and sender, right? Exactly, Surendra. So those source and destination IP addresses will help these routers in routing message, and the message that is essential for your message to reach to destination. Without the IP address, it cannot be routed, and would not be able to reach to final destination, right? Second thing, once it reaches destination will have to send a response back to client, right? See, client server architecture is actually request response model. The response cannot come back to your client if its IP address is not known, right? This is why source and destination IP addresses have to be there. Mohana, any app can use ESP8266 as a Wi-Fi module. Okay. Okay, so I got answers. My question was, do we need a new layer, or do we need, can we assign this job of breaking message into pieces to one of these layers? And the answer is, and I've got this response, this answer from multiple participants in chat window, from Ajay, and from Jiten. He says a new layer has to be inserted. Chandrasekhar, okay. Okay, so guys, the right answer here is we'll have to insert a new layer between, application and data link layer. Okay, and this new layer that we are supposed to insert over here is going to be a software component. Okay, it's going to be a software component, just like a driver. You install a driver on your computer, right? So this software component has to be there, to take care of this job. So on this side, this software component will be responsible for taking the message from application layer and then breaking this message into pieces and appending IP addresses with them. Once this is done, then this layer will hand over those packets to data link layer, physical layer, to be handed over to this router. Where in this router would be responsible to forward those packets in the forward direction to be routed to final destination. Okay. Now, question is, what should be the name of this layer? And name has already been shared in chat window by other participants. The name is network layer. Okay, what is the name of this layer? Network layer. Okay, and the protocol we use on network layer is called IP protocol. Okay, now we need a similar layer, a peer layer on the server side too, right? Why? Because when these packets reach to their destination, data link layer will be responsible to collect these packets from the physical channel. Okay, and data link layer will hand over these packets to network layer at the peer station, and this network layer will look at the IP addresses to verify that yes, these packets are destined to be delivered to this server. Getting the idea? So network layer have to be on both the systems. Okay, plus we'll also need this three layer physical data link and network layer on every router. So every router over here on internet is a three-layer device. Why? Because routers would be responsible to receive the packets from network, and receiving can only be done if routers are physically connected to network, right? To enable these routers also computers, so to enable these routers to receive the packets from the network and then analyze them, look at their IP addresses, and then route them. What do you need? You need network layer. Only network layer understands, and it's a software application, software component. So only this software understands IP addresses. It means every router will have network layer running on it, right? To enable it to understand IP addresses, and once it understands IP addresses, then only it will be able to forward it. Okay, is this clear to all of you? The role of network layer. What does network layer do? Network layer is responsible for breaking the messages into packets, appending IP address with them. Network layer is also present on all the routers, where the job of network layer is to analyze IP addresses of content in those packets to route the messages in forward direction. Means routing is also the job of network layer. Okay. Okay, so once we have understood this thing, and we the network layer over here, let's say we hand over message to network layer, and then the network layer breaks it into pieces, and then these packets are handed over to first router. Now what next? So this router will look at the IP addresses and forward these packets in the to reach to final destination. But all these packets are not going to follow same path. Why? Because you know the internet is a decentralized network, and here this packets will follow different routes based on availability, traffic conditions, and congestions. Okay, so it may happen that this router sends two of the packets to this router. Okay, sends three packets to this router. Okay, now here, this router decides, okay, I'll send one of the packets to this router, because here the traffic conditions are not get that good, and here the bandwidth is proper, so I'll send two packets to this router. Okay. Now these two packets will finally travel this path to reach to server. Okay. This packet will follow this path to reach to server. Okay, and this packets will follow this path to reach to server. Okay, so path taken by packets may differ. Okay, now because of this thing, it may happen that your packets will not reach their destination in the sequence transmitted by your client. Getting idea? The packets may reach to this destination in a different sequence than they were transmitted. Right? Second problem is the it may happen that some of the packets will be lost or corrupted because of network issues. Okay, it means integrity of your message could be compromised at any point of time. Okay, so here once these packets are collected by physical layer and data link layer and handed over to network layer, once network layer has verified that yes, received packets are supposed to be delivered to this server only, then there has to be a software component, right? There has to be a software component to verify integrity of the message, right? Whether message, because message has to be recreated. So first, this software component will have to, you know, combine these packets to each other to recreate the message. Once the message has been created, there has to be some kind of processing to verify the message, whether the message carries the same meaning. Okay, so let's say from here you send a message, how are you? And what if it doesn't reach there is how are you? What if it reaches only how? No are you, right? Getting the idea? So this is the problem, right? We cannot afford a loss of the packets because loss of the packets means you are compromising on the meaning of message. Okay, so there has to be a component over here which would be responsible for a recreation of the message, which would also be responsible for checking whether your message is error free or not, or whether your message can be accepted as a valid message or not. And if not accepted, this layer will have to send a message back to the client to retransmit the message, right? It means the software components have to be on both the sides, right? It means we'll have to interface or I would say insert one more layer between application and network layer, and this layer would be responsible for this end-to-end reliable and error-free delivery of the message. Could you guys guess name of this layer? Okay, so I got the response from Mohana. Yes, the name of this layer is transport layer. Yes, so the job of transport layer is to ensure end-to-end transport of message. Okay, I'm just putting TR here. TR means transport layer. So on both the system, you need this protocol stack. How many layers? Just drop your answer in chat window. Number. How many layers do we need on both the systems to make this communication happen over internet? 5 layers. Can internet communication happen without support of transport and network layers? Answer is no, right? Okay, so the question is here, see, in our system, we have Arduino connected to Wi-Fi router, right? ESP01 is acting as data link layer and physical layer. Our serial monitor is acting as application. Again, not running on Arduino, but on our laptop. Now, question is, do we have this transport and network layer somewhere in our setup? Yes, no? No, Somajit, it has to be on our system. Okay, now see, on Arduino board, ATmega2560, right now we are using serial monitor. Later on, we'll put an application directly on our microcontroller. which would be responsible to communicate with ESP01 as well as sending this message, which is written at the top, the HTTP message to server. But anyway, right now we are just doing everything manually. Okay. So our 80 mega 2560 microcontroller doesn't have this network layer or transport layer software components embedded in it. Okay. Laptop, because this is not going to be part of our sensor node, once it is complete, we are just using laptop for manual testing. Okay. So forget the laptop. Okay. Now the only component which is there in the system is ESP01. Okay. My question is, are these layers available on ESP01, transport and network layers? Okay, and the answer is yes. Okay, see, ESP01 is really, it's a high-end, SoC, system on chip. ESP01 has all these four layers inside it, not just Wi-Fi. It's not just a Wi-Fi module. It's a full-fledged, you know, solution. Okay, this chip, tiny chip, has transport and network layer software component embedded in it on chip. Okay, and this could also be configured using 80 commands. So you can simply send 80 commands to select a transport layer protocol. Now when it comes to transport layer, there are two protocols we use, or there are two protocols which are available over here: TCP and UDP. you know TCP and UDP. Transmission control protocol and user datagram protocol. TCP is a connection oriented protocol. So it's something like, say, uh, what does transport layer do? Transport layer is just like a courier service provider. You have a message. Okay, so let's say you act as an application, right? You write a letter for your friend. Okay, so you are acting as application layer. Now this letter has to be delivered to your friend, which is another application at the other in another city. To send this letter to your friend, you need the services offered by a courier service provider, and this courier service provider is this network stack. Okay, so you go to a courier service provider as an application. Go to a courier service provider. In this case, courier service provider is transport layer. Okay, and you ask what kind of services do you offer? So courier service provider says, okay, we offer two types of services. One which involves getting an acknowledgement of the message from the receiving party. Okay, so we'll guarantee the delivery of this letter. At same time, we also will also provide you an acknowledgement, a receipt of receiving this letter, by the uh, party at the other end. Okay, this is what TCP offers. So whenever application hands over message to transport layer here, and if protocol selected is TCP, it means transport layer will offer a service to application layer. This transport layer, will not only send message using internet to server, but will also demand an acknowledgement from this transport layer, which will be handed over back to this application once received. Okay, so this is what TCP does. TCP is a reliable and acknowledgement based transport layer service. Okay, UDP does not get acknowledgement, and this is not reliable. It is, we call it connectionless protocol. Okay, so UDP simply believes in fire and forget. Okay, so it's something like, as an application, you go to a service provider, a courier service provider, for example, transport layer, and the courier service provider says, okay, I will take your message, I'll send it to the receiving party, but do not expect an acknowledgement. Second thing, I cannot guarantee delivery of the message. That is UDP. Okay, so TCP guarantees delivery of message. UDP does not guarantee delivery of message. Okay, but because TCP guarantees delivery of message, it's a complex protocol, so there would be lots of handshaking involved between two parties, and that makes the entire communication process complex and slow compared to UDP. Okay, UDP is simpler but not reliable. Okay, so now choice is yours. Which out of these two protocol you would choose, right? So when it comes to reliable delivery, for example, let's say if your client has to submit username and passwords to a server, a remote server, in this case, you would prefer to go for TCP. You know why? Because loss of a single packet cannot be afforded, right? Because if there is a single characters or single packets error in your message, your server will discard your credentials. Getting idea? But when it comes to other application, for example, music and video streaming, okay, in this cases, loss of few packets will not make any difference. Okay, so you can easily afford loss of packets. What you need over here, because it's a continuous stream, you cannot wait for acknowledgement to come back from a receiving party, right? So in this type of cases, you would prefer to go for UDP. Okay, so with the advent of IoT, UDP is gaining popularity, because this is what we need over here. We need simpler protocols, which could easily be implemented on resource constrained systems and does not overload them, you know. So UDP is less complex, lightweight, not reliable, but in most of the IoT use cases, even if you lose, one or two, uh, values, it won't make any difference as long as your applications are not mission critical. Okay, so UDP is uh, gaining popularity in the IoT domain, but TCP is still there, because we do not have any alternative. TCP is highly reliable. So in UDP is not going to replace TCP completely, but there is a tough competition between TCP and UDP. Okay, the good thing is this ESP01 module, it comes with TCP IP protocol stack. Okay, and IP, it supports IPv4. Okay, so we have our complete stack now. We have TCP IP stack on ESP01 module. ESP01 module also provides us data link and physical layer services. Okay, so we have entire web stack or this 4-layer stack available on ESP01 module, which could easily enable any microcontroller which is capable of just hosting your application. It can help that microcontroller turn into an internet communication capable microcontroller. Is this clear to all of you? Any questions from here, guys? In case if you have any question, please raise your hand.
Hello. Hello. Sophie, can you hear me?
Ajay, can you hear me? Please unmute
Yeah, I
yourself.
can hear you.
Yes, yes,
Yeah.
please continue.
Yeah. What are the protocols supported by network layer?
So network layer, there is only one protocol. There's no other options, and that protocol is IP. But IP
Oh,
has two versions, IPv version 4 and IPv version 6. IPv
okay.
version 4 uses 32-bit IP addressing. Okay, and IPv6 uses 128-bit IP addressing. You know, when we connect systems to internet, it applies to all the types of computers, laptop, desktop, mobile phones, TV, whatever you connect to internet. You know, this
Mm.
systems are gonna get a unique identity on internet. Unless they get
Mm.
unique identity, they do not become valid node on internet, right? And IP address is a mechanism to identify uh, you know systems or network nodes on internet uniquely.
Okay.
Okay,
Yeah.
so a system has to have an IP address. Okay, so there are two versions of IP addressing. Version 4, which uses 32-bit IP addresses, and with the help of
Yeah.
32-bit IP addresses, you can uniquely address 2 raised to the power 32 systems.
Yeah.
And if you convert this, it comes to millions, right?
Mm.
2 raised to power
Yeah.
32 comes to millions. So you can have millions of systems connected to internet, and these systems will have unique identifier associated with them. This identifier are called IP addresses. But now with internet, with IoT, the number of network nodes are growing. It means we need more number of IP addresses, right?
Yes.
Why? Because there are more number of nodes, and each node will require a unique IP address, right? So this is the reason why IPv4 is getting replaced with IPv6. So IPv6 uses 128-bit IP address, and that allows us to make combinations. 2 raised power 128 combinations. If we calculate, this goes into trillions and trillions, right? So we will have trillions of IP addresses available to them. With the help of IPv6, we can address trillions of devices uniquely on internet, right? So IPv6 is going to solve the problem of requirement of more number of IP addresses with its 128-bit addressing scheme. I hope this
Okay.
answers your question.
Yes. So network layer will have only one IP protocol.
Exactly. So network layer, it's
Yeah.
kind of hourglass figure, because at application layer, we have so many options, right? Application layer, we have HTTP, we have MQTT, we have CoAP, we have this AMQP, and we have many other application layer protocols. For example, we use AT commands, right? All these are the options when it comes to application layer. At transport
Okay.
layer, we have TCP and UDP, and network layer
There are only two.
we just have IP. Yes, at transport
No,
layer we
I
just only two
only.
TCP and UDP. Yes, at the
Okay.
bottommost layer, if you look at the data link layer, here we have so many options, thousands of options, right?
Yes.
Wireless,
Yes.
wired. In wireless, we have Bluetooth, Wi-Fi,
Yes.
Zigbee, LoRa, Sigfox. So many options, right?
Yeah.
Cellular. Okay,
Yeah.
so uh, it's just like hourglass. Here we have more number of options, then it narrows down. Here we do not have, we just have one option, and then it again, you know here at the
Yes.
bottommost layers we have lots of options, right?
Yeah. Yes.
Okay,
Okay.
any
Thank
other
you.
question, Ajay?
No.
Okay, thank you.
Thank
Okay, Mona, just you're raising your hand, right? Mona, could you please unmute yourself?
Hello. Yeah,
Yes, Mona.
Shafi. If I use IPv6, is it that supports ESP8266 IPv6 address?
So ESP 01 does not support it. I haven't
Okay.
checked other ESP modules, but ESP 01 does not support IPv6. It only supports IPv4.
Okay. Do you
Okay.
suggest any Wi-Fi module which supports IPv6?
I will definitely find out and will let you know, Mona. At this point of time,
Okay. Okay.
I really apologize. I do not know the IP address. Okay, I'm going to
Okay.
say the module's name.
Yeah, yeah. And one more thing, Shafi, if I use IPv6 address at Wi-Fi module, does
Mhm.
my all access point nodes should support IPv6
So
or
most of
neither?
the modern generation SoCs and microcontrollers, if you look at the this SoCs from manufacturers like TI or Microchip, they come with support for both the protocols, IP4 as well as IPv6, because IPv4 has not been completely replaced by IPv6. IPv4
Yeah.
is still in use, right? So I would suggest you to select a SoC or any other module, assist, for example, a device which comes with support for both the protocols, IP4 as well as IP6, to maintain downward compatibility.
Okay. And the access points also, is there any choice to select, or I
Yes,
should
most of the
maintain?
Wi-Fi routers are coming with support for both
Okay.
IP4 and
Latest
IP6.
Wi-Fi routers I should
Yes.
select.
So this is the practice right now to build systems which support both IP4 as well as IPv6.
Okay. Okay.
Okay,
Okay.
because
Thank you. Yeah.
because IP4 is still in use. It has not been discarded, right?
Yes.
Okay, okay,
Okay. Thank you.
okay. Yes, Srinivas.
Yeah, Mr. Sheffi, are we practically going to see how to configure the MQTT brokers, those things?
Yes, yes, we will.
Okay,
So
okay.
I'll cover Mosquitto, which is an open source, MQTT broker solution, and we'll configure. We'll use Raspberry Pi as our experiment, platform.
Okay.
I'll teach how to build your IoT network using HTTP protocol as well as MQTT protocol.
Okay. Thank you. Thank you very much.
Okay, Srinivas. Okay, so this might have given an idea, and we have a couple of questions in chat window from Raj Surya. How can know the router supports the IPv6? So you will have to look at the document provided by manufacturer Raj Surya. Router, when you buy it, you will have to look at its technical specification, data sheets, whether the IPv6 is supported or not. Okay. Balamurugan has a question. It says, "Do DL layer 2 have different versions of protocol?" Yes, Balamurugan. So we talked about Bluetooth, right? Bluetooth has so many versions, and there are compatibility issues within versions, right? And Wi-Fi has so many versions: A, B, G, N, H. This module, the ESP01 module, supports BGN. Okay. Zigbee also has many versions. Zigbee has simply come with 3.0. Okay. I hope this answers the question. Okay, Balamurugan has a question. It says IP refers to network layer. Exactly, yes, Balamurugan. IP is the protocol we use at network layer. So layer's name is network layer. Okay, I explain you its role, and this IP is the protocol. So protocol means how is that work done? Okay, see, network is the name of the layer. Okay, protocol means the right way of or the rules to get that job done. Okay, so IP is the protocol which is used at network layer. TCP and UDP are the protocols used at transport layer. Okay, guys, so as I just mentioned this thing and explained, ESP01 has transport and network layer embedded in it. Okay, now how to verify it? Okay, so there is a simple way of doing that. See, we have ESP01 module connected to our laptop. Let us practically test it. Okay, we can configure ESP01 module as a TCP client. Okay, and to do so we will have to use this commands. Okay, so for example, first command is AT plus CIP mux equal to 1. This command will configure your module to act as to work in multiplexing mode. Okay, so when you use this command AT plus CIP mux equal to 1, your ESP01 module start working in multiplexing mode. Means and it provides you 5 concurrent channels, to communicate with a server. Okay, in our case, we'll go for a single channel communication. So to disable multiplexing, what you can do, you can issue a command 80 plus CIP mux equal to 0. Okay, so let us do it. If you have your ESP01 module connected, go to your serial monitor and send command 80 plus CIP mux equal to 0. Your module should respond with OK, right? Does it do? Send 80 plus CIP mux equal to 0 command from your module, from serial monitor. Your module must respond with OK. It means your module has been configured to work in single channel IP communication mode. We have configured its network layer. Okay, and now let us configure the transport layer. Okay, to configure the transport layer, we'll send a command 80 plus CIP start. Now what does it mean? Starting IP communication. Okay, equal to, you will have to select a protocol. So protocol we're gonna use is TCP. That is the only protocol available. We'll put a domain name of a server, www.google.com, and then at the end, okay, I forgot to put a double quote here. I'll share this syntax in chat window. Okay, don't worry. Then comma 80. Okay, so this is the command you can send. Okay, you send this to your module ESP01, and once you issue this command to ESP01, ESP01 will connect to google.com. Okay, sorry, there is an extra. Okay, it says connect. Okay, so see this, we are sending this 80 plus CIP start equal to TCP, and then this address comma 80 is the port number. I'll explain this thing later, most probably in tomorrow's session to you. Okay, 80 is the logical port number on which HTTP communication takes place between two applications running on both the ends. Okay, so try this command. This command will connect you to Google server. Okay, and then you can use this command 80 plus CIP send. Okay, equal to some number. Okay, that number represents number of bytes that we wish to send to server. Okay, you can put any number, because the number has to be this number means the number of bytes or characters in our message. So anyway, we are not going to send any message, so you can put any number. Just send this, and if in response to this command, if ESP01 module returns this symbol, okay, this symbol, it means now ESP01 modules is ready to communicate with the server at the other end. Okay, end-to-end connectivity has been gained. Please test these 3 commands and let me know if it works fine for you. If you receive this prompt, the symbol, it means your module has been connected. End-to-end transport connectivity has been gained. Cool, right? Okay. So let me once again, help you understand this protocol stack. So as we have discussed so far, there are two networking reference models, which act as, a guideline for network designers. OSI model talks about 7 layers from physical to application, and the role of these layers, as I just explained, have been specified here in this table. Physical layer is responsible for physical data transport. Data link layer is responsible for host-to-host physical connectivity. Network layer is responsible for addressing and routing. Transport layer is responsible for end-to-end connection and reliability. Session layer is responsible for session management. Presentation layer is responsible for encoding and encryption. Application layer is responsible for creation and interpretation of the message. OSI model talks about the 7 layers. TCP IP model designed by or derived from OSI model by IETF. IETF stands for Internet Engineering Task Force. TCP IP model has combined application, presentation, and session layers into one layer, and that is application. Okay, so they're combined. They have, combined session and presentation layers in the application layer itself. Okay, so these two layers are not there in TCP/IP model. It's only application directly running on transport, network, data link layer, and physical layer on top of this. Okay, so the model we are employing in our case is TCP/IP model, right? 5-layer model, as I just explained, and this is what this entire set is inside ESP01, and we have learned how to configure data link layer present on ESP01 to connect it to Wi-Fi router physically, and then we have also learned how to configure its network layer and how to configure the transport layer hosted on ESP01. Okay, so this is what we have learned in today's session, right? We will learn interfacing ESP01 module with our Arduino board, and we have learned configuring ESP01 manually, connecting it to our router and configuring its transport and network layer to make it ready to communicate with a server on internet. Okay, is this clear to all of you? Cool. So I think because I don't jump to our next topic. The next thing is, now whatever we did manually in today's session, in the next step we will put our application directly on Arduino board. Okay. See, our Arduino board is connected to internet now with the help of ESP01, right? So what we'll do, we'll put our application directly on Arduino board, and application will communicate with ESP01 not only to gain connectivity but also to deliver this message which is expected by our server. Getting the idea? Now this is what we are going to do in tomorrow's session, so please do not disturb your hardware setup. Let your hardware setup be as it is. In tomorrow's session we will directly write an application on our Arduino board to not only capture this data from this sensor but also send this data in the form of this message to this server using transport, network, and data link layer services offered by ESP01. Okay, I hope this is clear to all of you. Raj Surya, this video would be available on LMS, within 1 hour or within an hour. Okay. Okay, thank you guys. So thank you very much for this interesting session. See you tomorrow with our next step. Okay, and I'll repeat again, do not disturb your hardware setup. Okay, keep it as it is. Venkat, I will have to make some updates in it because it's an older version, and I'm still working on this PPTs. Okay, so I'll try to share it in this week. Don't worry. Okay, I'm just updating my PPTs. This is why there are few topics which are not in sync with in that plan and in my delivery. Okay, thank you guys. Good night. See you tomorrow same time. Take care.